Hello, everybody here. Welcome to choosing a model for 3D printing. I'm Connor with DoSpace, and today I'm going to be hoping to give you guys a little more info for the next time you come into DoSpace wanting to print something. It may be your first time doing a 3D print and you may be interested in getting something done, so we're just going to go over a few guidelines so that your first print will most likely be a success. This is going to be oriented more towards beginners, people who haven't printed before at all, or someone who might just need a refresher about 3D prints and what they need to look for when choosing a model for 3D printing. All right, so let's get right into it. So I'm going to be talking about a few things in general. So first, about how FDM printers work. We're going to be talking about strictly FDM printers. We're leaving the SLA, SLS, all the fancy 3D printers out of this one. That's a little bit farther up the curve. We're also going to be talking about 3D printing materials, the filaments that we'll be using, and what to keep in mind when choosing a filament. Some of the weak spots of FDM printers where they might struggle to get a print done. Some basic rules for choosing a 3D model. They're more suggestions than anything, but if you follow these, you're going to get a fairly good print no matter what printer you use, and a few different places on where you can get some 3D models. All right, so first let's talk about how FDM printers work. FDM printer, or FDM, stands for Fused Deposition Modeling. It basically just means using a filament or a material that is fused selectively in layers to build up a model from the ground up. I like to think of it as just taking a regular 2D inkjet printer and then printing over that same page over and over again. It's a little different, but that's sort of the idea behind it, just building up each layer one by one, piece by piece. To actually get that filament to become malleable and form the way we want it to, we heat up different plastics to its glass transition point. This is the point where it becomes less of a solid, where you can stretch it and mold it, but not liquid enough to actually flow around and melt like the way you would when you were heating up chocolate. Now, FDM printers have a few good qualities for them. It has an accuracy of around +1 or -1 millimeter. It's also fairly cheap to print on an FDM printer. They're everywhere now. You can get a printer for around $200, or you can come to somewhere like DoSpace and print for, in most cases, less than $1 while you're here. So when we do go to print, we're first going to take our model. We're going to slice it into the layers using the slicer, something like Cura, which we're going to be using today. XYZ printing is the slice that you would be using if you're using our DaVinci's. Or Simplify 3D, a higher end slicer, which you might find in a more professional setting. So as we already went over, a FDM printer extrudes molten plastic in layers from bottom to top. It's less of printing out a whole area like you would on a regular 2D paper printer, but it's actually laying it down line by line, building up those lines as we were talking about. So next thing I want to go over is keeping the material that you use in mind. There are just loads of different plastics available for 3D printing. Um, there's a few that I would probably recommend for a beginner. These are going to be our PLA and ABS. And then we have a couple down lower for more exotic materials. Say you'd need to do a more production build. Starting with PLA, PLA is sort of our go-to plastic for everything. It's great for just getting started with printing. If you're printing something meant to be pretty, like a little statue, maybe a phone holder, just something small, I would probably recommend the PLA. It's super easy to print with. The only thing with PLA is that if we wanted to use it for a functional piece or part, we have to keep in mind that it doesn't bear loads as well as some of our other printers. You could still easily rest your phone on it, make something for like a Nintendo Switch games holder. But if you're gonna try and like put a bunch of stress on it, it's going to be more likely to break, which is where our next material, ABS, pops in. If you do have us print something for you, this is where we're going to print it in. It is susceptible to warping during printing, meaning it's harder to print with. We need a bigger 3D printer that has a heated bed, a heated chamber to prevent it from cooling down while it's printing too fast. But it is more resistant to stress. It's a little bit more flexible. Not that you could bend it per se, but that it's going to take hits a bit easier. We also have PETG, which combines sort of the best of PLA and ABS, where it's easier to print with, and it can also stay strong under loads like ABS. It also has a few other properties, such as being FDA approved for food consumption. So if you did want to print dinnerware like a plate or a glass on it, that would probably be a go-to plastic, but I personally wouldn't recommend printing anything you would eat off of. Um, Bacteria can still hide in those cracks and they're super hard to clean and sanitize. It's just not really something I would do. The last plastic I'm going to be talking about, or just referencing in general, is nylon. Nylon is a lot harder to print with. It's a lot pickier than ABS, but it is also a lot stronger. Nylon is also used in industrial settings, such as custom machine at Freddy's, and a few other places. All right, now let's go over some of the weaker points of FDM printers. FDM printers, while cool and they can print almost anything, there's a few things that we're going to want to keep in mind when we're choosing a model to print with an FDM printer. If we want to print, say, like a little statue that has arms out, we'll want to remember that FDM printers cannot print directly in air in most cases. So we're going to want to add supports underneath those arms to make sure it can print. A good rule of thumb is to keep everything under 45 degrees. If it's leaning over 45 degrees in the air, it's probably not going to be able to print. But as long as we keep the angles that it's printing at within that triangle, and I'll make sure to show you an example of that later, it should be printable. Another thing to keep in mind is lines introduced weak areas. The problem with FDM printing is the lines that it introduced. You might have seen, if you've seen a 3D print before, that it's a little rough around the edges, or that you can see all those lines going from the bottom to the top. Well, those lines are technically weak points. If you're bending something across those lines, it's more likely to break where two lines are joined. rather than along the line. So as long as it's along the line, the part's going to be physically stronger. And you'll want to keep that in mind if you're printing something for a functional prototype, or also if you're just trying to make something look pretty and have all the lines like that, just straight up and down. It's another thing to keep in mind when you're orienting your model. Next, let's talk about details. Details are hard to produce on an FDM printer. It does have that accuracy of about 1 millimeter, but there are a few things that it does have troubles with. It's not very good at printing small objects. So if it's something that is fairly detailed and under 2 inches, I would either find something else to print or explode it and make it larger. You can always take a model and make it bigger. That's just going to increase the time that it takes to print. What you will want to look out for are the wall thickness of your model. You want it to be at least 0.8 millimeters for it to stay solid. Embossed and engraved details, that's like if you took some lettering and had it stick out of the model or pushed it inside of it. It's most printers don't handle that fairly well. So you'll want to make sure it stays about at least 1 millimeter thick, possibly even bigger, just to make sure that that text does come through. There's also the minimum features that we wanted to talk about, and this is mainly relating to if we had something like a pillar, wanted to be at least 2 millimeters thick in diameter, in order for it to actually print correctly or to prevent sort of a misprint, making it look sloppy. And then there's a few other things to look out for, but if you're mainly looking at for these details that we went over, you should have a successful print. Next thing that we'll talk about is small prints will most likely look sloppy on an FDM printer. The nozzle prints a set diameter up element, which is usually going to be around 0.4 millimeters. So you'll want to make sure that your model is fairly large. I would say 3 inches would be a good place to go for. They're 3 inches tall, 3 inches wide. That's going to give you a lot more quality, or not a lot more, but it's going to increase the quality of the print as you increase the size, as it has more area to work with for the smaller details. The last thing you are going to want to keep in mind is the time it will take to print. The larger you do make something, the longer it will take to print. And I've found in some cases that the print time has quadrupled when you are growing it up to about twice the size. So larger in general prints, like a medium large, good. Like super large, like foot tall prints, probably not so good of an idea. All right, and now here's some of the basic rules, more suggestions of the printing. Make sure a print is supported. We were talking earlier about that 45-degree angle that we're trying to keep. And basically, if it does go over that 45-degree angle, it doesn't mean it's unprintable. If we have a part that has 2 pillars in between it and we need to print solid above it, the printer is actually capable of printing on air in that case specifically. It's a feature called bridging, and that is when one piece of filament travels across a line to another pillar. If we do need to print over 45 degrees, we'll want to enable support, which is going to print extra filament that we can tear away later. And that's going to give it a place to lay down on as it's printing out. You're still going to get your whole model. You might need to clean it up a little bit, do a little bit of sanding underneath some arms from some characters, but as long as you do have that support, or you keep in mind that you cannot print in air, you should be quite all right. Choosing that model with less details and larger features, so we can blow it up, or we can choose a simpler model, which is probably something that I would recommend. A hyper detailed model is not going to turn out well on an FDM printer, but if you choose something like a low poly Pikachu, we've seen some of those printed here at DoSpace. Those don't have a lot of detail. They are great to print with. Last thing, if you do submit a file, make sure that your file is an STL file. This is the main file type that you'll want to use when we're 3D printing. It's fairly standard, and it will help with compatibility issues and making sure that it does print right the first time. Last thing that I thought I would touch on for some rules of 3D printing, if you do want to increase the strength of a model, you're going to want to increase the shell thickness. There's a couple of settings when you're printing, shell thickness and infill. Shell thickness is how many layers the wall of a 3D print has. That can be like 2 or 3 layers of those lines of plastic. Can be anywhere up to like 10 if you're really crazy. And then there's also infill, which is the amount of volume taken up by plastic. And you'll see it in percentiles such as 15 or 20%. Generally, for most prints, I would recommend 15%. It's a good fill to budget ratio. In some cases, you could probably get away with 10% infill, 10% being plastic, the other 90% being air. But 15 is a good happy medium. If you're going above that, you've got to find a good reason, I would say. All right, and here I've listed a few places to find 3D models. And a few places for if you wanted to make your own 3D model. So for finding a 3D model, the thing that we usually recommend is Thingiverse. It's sort of the largest, I would say, just website in general for finding 3D models. If you want something and you don't know if it's made, I would check there first. They will most likely have it. My mini factory is kind of like Thingiverse. It's also fairly large, but it's more curated. Their whole motto is making sure that it's printable. Thingiverse can have anything and everything, sure, but it's also going to have a lot of unprintable 3D models, whereas the My Mini Factory will make sure the models are clean, and it should have instructions on how to print that model if there's anything special you need to do. Last one is yegi.com, and this is sort of like a search engine for 3D models. Think of it like the Google for 3D printing. It's going to go to multiple websites like Thingiverse, My Mini Factory, and a few others. And it's going to put them all in one place for you to find. You're more likely going to have unprintable models looking at Yegi, but if there's something that you absolutely must have, I would say check Yegi out, see if you can find it there. For making models, we have a few tools, and we have it listed from beginner to more intermediate and advanced. Tinkercad is what I would start with if you wanted to try 3D modeling on your own. It allows you to build with shapes to sort of build a project up. we've had some elementary schoolers coming in using it to build their own little ships and flowers and whatnot. But if you did want to get started, I would probably check that out. SketchUp is going to be a bit more advanced, a bit more technical. If you need to have exact dimensions, something simpler, blocky, geometrical, SketchUp would probably be the place to go. It's a little harder to work with though, so you will need to put in a little bit of effort learning how to use it before you can make anything functional out of it. The last tool that I could probably recommend is Blender. This is more advanced. There's going to be more pitfalls when using Blender that you'll have to look out for. Inverted normals and whatnot. So if you are a seasoned professional with 3D modeling and you want to make something, you could probably use Blender. You'll be able to make more detailed models with smooth instead of hard edges. But for the beginner, I would not recommend Blender to begin with. And then we also have a few different resources for if you do want to get a model printed and you don't have your own printer. Shapeways, I would recommend if you need something printed in an exotic material, such as solid metal. I believe they print in gold and silver in some cases, solid steel, they have resin printing. I also believe they do full color printing. It is going to be a bit on the pricey side, but if you need something done, they are going to be able to handle it fairly easily. Otherwise, if you want to try printing something out, I'd head over to DoSpace when we do open up again. We have our DaVinci mini makers for just getting started, just trying out printing for the first time. And we also have a few more professional tools, such as our TAS if you want to build a more complex model and want to make sure it does come out sizably correct. If you do need something done in a professional fashion, we also offer printing services where we will print the model for you. It has a soluble filament that will melt away, guaranteeing a perfect print every time. All right. Now, let's go ahead and look at an example of something that you could 3D print. This is Benchy, the little torture test boat. And this little guy I like to use when we want to talk about some of the things that you'll want to look out for when printing. So first thing that I'd like to point out is the angles that I was talking about. If you couldn't really visualize that, well, this is what I'm talking about right here. You can see this boat stoops up at an angle towards the front. And if we look underneath it, you'll see the red. This is highlighted because it's over that 45-degree angle zone where it most likely won't print correctly. If you see above it, the angle becomes much steeper, and this is because it has a place to actually print on top of. It can branch out a little further each time, but once we hit that 45-degree or about right here on the boat, if you can see my pointer, in that red area, that's where it's going to have a harder time printing. You can also see that with the ceiling of the boat, just anywhere it's highlighted in red. Now let's also take a look at that embossed text that I was talking about earlier. This is, if you can see that little rectangle sort of on the butt of the boat, that is text that's been pushed out away from the model. This text is going to be harder for the model to print, not only because it's not really attached to anything physical, but it's just jutting out at an interesting angle. That and with the small details on it, such as the hashtag 3D Benchy that you see it right there, the printer's going to have a harder time making sure to get that written out correctly. It might even just erase it on some printers and call it good. If we look underneath it, we have an engraved text. This text, instead of being pushed out of the model, has been pushed inside of it. Now it's larger, so it's going to be more likely to print, but you do want to make sure that it is about 1 millimeter, 2 millimeters thick from edge to edge on the inside of the text. So here's another overhang right here, the arch of the doorway. Now this is more likely to be successful than just printing out into the air, because it is going to have something that it can bridge to eventually, but you're probably going to see some strands of filament just hanging off from that door frame after the print, and that we can easily clean up. Another thing to keep in mind are holes. This is something I believe I failed to mention, but printers do not like holes very much. They like straight lines, rigidity, and wide sweeping curves. Small holes, on the other hand, it does not do so well with. Something like this should be fine, but if you had a technical print that you needed to have an exact diameter hole, you'd want to make sure it is bigger than 2 millimeters. I might even say 3 millimeters in diameter. Last part right here, if we look at the ceiling, if we can just sort of get inside here, you can see that it's red, it's printing in air, but it's fine because it is going to be able to make a bridge between the left side of the ceiling and the right once it gets to that point. Now, when you are bridging, you want to keep it at a specific distance or underneath it. It can only go so far with one strand. I would say about 10 millimeters is as far as I would push it. You might be able to go a little bit more, but I wouldn't recommend it. But anything under 10 millimeters should be fine when it comes to printing. Alrighty. Now let's see if there's anything else that I could point out besides the edges on the ceiling and that pipe right there are probably not going to have as good of a time. We have more embossed in this circle right here, the little steering wheel. So normally this isn't a print that I would recommend printing, but this is meant as a torture test. It's supposed to show you the limits of your 3D printer and see how far it can go. Now, with the last few minutes that I have, let's look at some of the website I was talking about earlier. So you can see right here, this is Thingiverse. These are just a few examples of some of the models that you can print out, like a little mechanical phone holder with quick grab and release, a flexible cat. We've actually printed a few of these flexible animals at DoSpace. They are a joy to print out. Fairly easily printed, and they're pretty cool after you're finished. Here's a sword handle. Now this one is a bit tricky. I would say you probably could handle, but printing weapons in general probably is not a good idea. So I would stay away from weapons such as knife handles and more things like that. Now this project that you see here with the rotating jar is less of a 3D print and more of a compiled list of 3D prints. There's a lot of things that you could do, and this is where I was talking about a technical 3D print if you needed something with exact dimensions, that you keep it within certain tolerances. If we head over to My Mini Factory, it's sort of more of the same. If we did want to explore, you can see that they have different sections for pretty much anything, such as cosplay, items in the world that have been scanned, fan art, board games. If you wanted to print out some special chess pieces, like this minion set, that's kind of funky. Um, but yeah, these are all things that have been printed before and can be printed again. So I would recommend checking out My Mini Factory and talking to us while keeping what we've talked about in mind. Here's Yegi. This is sort of a last resort if you did need to find one item specifically. They've got everything from spool holders to helmets, and they're pulling from multiple websites such as Thingiverse, My Mini Factory, and probably a few proprietary sites that you would need to pay for the models on. If you do find those models on this site, you will still need to pay for them, but you will be able to find them easier than looking for different sites and trying to find them. All right, and then here's the Shapeways. I wanted to just go over some of the materials that they offered real quick, show you some of the possibilities of 3D printing on this versatile plastic, which I'm guesstimating is flexible and strong, solid steel. These are some of the resin prints, the Akira 60 and Akira Extreme. These are great for tiny prints, some miniatures, and a few others like that. They're printed with lasers, you can get high tolerances. We also have our copper, gold, silver, platinums, gold plated, where they won't print it out in gold specifically, but they'll probably print something in wax and then melt away the wax and replace it with the gold. All right, aluminum, plastics, full color printing, sandstone, and even more. That is something to take a look at. While you're at it, if you just want to print something in plain old plastic and you're in the Omaha area, I would check out Do Space once we open again. We will be closed until May 1st, but when we do get back to that and we do open up full services again, this would be a great place to start your first project. Alrighty, this has been Con with a Do Space. Thank you for joining us today. Hope you have a good one.